New state-of-the-art models such as Fable 5 or ChatGPT 5.6 do show incredible possibilities when you can be connected with Unreal Engine, Blender, and NoCap can help creating games and more. We just got released Unreal Engine 5.8 with new MCP, and it goes even further. But what about local LLMs? I believe you also keep hearing that local LLMs keep getting better. But do they really? That's the question for today's video. I did run open source LLM on my computer and tried to build full game. Spoiler, I actually did that, but it's not really what you think about. There are a lot of details and bottlenecks that I need you to know. And before we start, guys, I really need you to hit that like button. This video was very difficult to make. I almost abandoned this idea, but I think it will be very valuable for you to know what's the real experience working with local LLMs and trying to connect it with Unreal Engine or any other MCPs, maybe Blender. Anyway, I'll cover all of that in a bit. Let's start step by step. First thing first, we need to find a good model that will also fit our VRAM. Well, I'm the lucky one and I do have 24GB VRAM. And I know that's the top edge of consumer's grade GPU. I'm having NVIDIA 1590. However, for general use LLM, that's actually very low. And we're gonna need to find GGUF version at least. I already did the research, a lot of testing in the background, guys. You cannot imagine how much I tried. And the best candidate is Qwen 3.6 with 27 billions parameter GGUF version by Unsloth. And this one is quite unique. First of all, it actually works really great and delivers really good results. Well, and the first question, of course, you ask me how good it performs. And here are the benchmarks. This model is able to perform on the level on Claude Code 4.5 Opus, which is actually quite impressive. And it's gonna fit my 24GB. In fact, it actually gonna fit 90 to 20GB. I'm gonna show the settings that I used. There will be some details, but you also need to keep in mind if you're about to run it on one computer, you're gonna need some extra space for system in Unreal Engine itself, right? Now, how do you install it? We're gonna need Llama.cpp. And pretty much you can actually go here in GitHub and pretty much on Hugging Face, you can see the instruction, how to use it with Llama.cpp, and there is even a command to install Llama.cpp. But from my test, if you run this Llama installation, it will install it with Vulkan, but that's not what we need. We really need a CUDA that will be more stable. So that's why we're gonna go to Llama.cpp GitHub, and we're gonna go to releases. Here in releases, we're gonna go find, in my case, it's Windows, so we're gonna go for CUDA 13 and CUDA 13.3 DLLS. Those will be two archives that we're gonna need to export in one folder. I'm gonna create new folder called Llama.cpp on my C disk. And next thing is simple. I'm gonna just extract all files for both archives right here. And that's pretty much all installation. Now we need to open this folder in terminal. You can right click and say open in terminal. And now you can go back to Hugging Face and use one of these commands, which is start a local server or even run inference. Well, this command will allow you to talk with Qwen right from the terminal, but we don't really need that, but we're gonna connect it to a more convenient agent. My command will look a little bit bigger because I also gonna specify some additional parameters. I'm gonna collect all that information, put it into the guide, and link will be in the description, of course, absolutely for free. But long story short, those just additional parameters how I want to run it, such as cache, such as context size, such as ports, etc, etc. And if you run it with HF parameters, it will pretty much download it if it's not yet downloaded on your computer. And if you did everything right, you're gonna see something like this. Llama server is started and it is listening on this address. Alright, and now when we have model locally started, we can go to VS Code, or we can also use Cursor or basically any IDE. And what we're gonna need is to open the project folder. You can create that project in Unreal Engine and then just open it here. We're gonna run the agent right inside that folder. That pretty much makes sense. And in that folder, since we're gonna use native Unreal Engine MCP, you're gonna need to install that MCP. I have another dedicated video about that MCP. That's pretty pretty simple. There's just few commands you need to run in Unreal Engine. Now, the second thing, we're gonna need extension called C-Line. That is basically an agent with quite a lot of capabilities that we're gonna really need, and you can plug it with any local LLM, right? You can basically plug any LLM there. So when you activate that extension, here in the console section, instead of terminal, you can switch to C-Line. And here's how it looks like. And we're gonna need to set the settings. So we're gonna go to settings, of course, and here we are. So here we're gonna set the base URL as we discussed, and the parameters that we also specified when we actually run the model locally. So you pretty much can set these same parameters here. Also, you can go to features and see what things you need or not. And here I actually want to point out a few very important stuff. First of all, if you're gonna enable images, that will be additional effort on your VRAM and might exceed the memory. So be careful with that depending on the model you're running. This Qwen 3.6 support images, but I figure out to work comfortably, I had to disable that. Another thing is the context window size, and I'm gonna set it to 40K, and that will also be reflected in how we're gonna use the model. The thing is, the bigger context you get, the more VRAM is to process it every time in every step with every prompt. And I also gonna set the reasoning effort to none. And I'm gonna explain later why so. Technically, again, you can play with different settings, but I explain my logic a little bit later. Okay, now we can go back to C-Line and see if it works. However, before that, we're gonna need to check the MCP servers. It's very easy. You can click on the MCP button and you're gonna open the settings. Here in settings, it's again like all pretty default. You can ask ChatGPT to help you up, like to build up that JSON, and that's pretty much the same way as usual. But next important thing you probably not expect to see is that we're gonna need to create a master prompt or system prompt for our local agent. And here we can do that like this. You can go to rules, workspace rules, and here I'm gonna set the MD file, which look like this. The system prompt basically look like this, which already describes what we're gonna build, what is this agent, and it describes quite a lot of details. Of course, I did not make this myself. I made it with the latest Claude Code model. By the link of the description, I'm gonna collect all the prompts, all the MD files that I use so you can explore them, so don't worry. But at this stage, I think I owe explanation why so. And I'll do that in a minute. You're gonna soon get a lot more clarity. Now, when we have system prompt set, MCP set, let's do the first test and ask it to check MCP connection to the Unreal Engine. And everything is successful. MCP connected. Now we're ready to start building. So my idea for this test was ambitious but simple because we're working with local LLM anyway, not Fable 5. But we're gonna try to get max of it. So I'm gonna build block stacking game, but with a burger. So the idea is very simple. We do have a bun and there will be different ingredients falling. We're gonna need to hit mouse button in the right time to release it, and the more perfect it falls, the bigger score, and we can grow until we reach the stratosphere. I want to try to do Niagara effects, some UI, etc. Everything except 3D assets and some background images will be done with Qwen local model. And now let's place first prompts. And here's the prompts, and you can see it actually looks very detailed. Let's run it and I'm gonna explain why. So the thing is, if you're gonna try to approach local LLM this is the same way they show on X, like using Fable 5, Clone Me, GTA 6, it's not going to work at all. Like, that's completely impossible with any model that you can run on consumer's grade GPU. But that doesn't mean they cannot do anything. They can access MCP and they can do a lot of tasks. But the second thing that we really need to keep in mind is the context. So if you're gonna provide simple prompts, Qwen image gonna need to think through it, and we're gonna need to set reasoning to high so LLM can come up with all these missing details. While if you provide all the details by yourself and be quite specific what you want, you can even disable reasoning, which I actually did, and it will be able to accomplish most of the tasks, such as, for example, I was able to make a Niagara effect as I requested, and that's pretty cool. And one more thing about a context window, since we do not want it crashed because of memory, every new task basically means new session within the C-Line. You can see I always click start new task, but you can see that I get my task done, and that is why I got my system prompt. That is sort of master context for my project, and that actually works. If you were expecting one-click magic with local LLMs, I'm sorry, it it's not. I'm here to tell you how it works exactly and what is the possible way to use it. And just like that, prompt by prompt, I'm building the game. Reasonable question from your side is, how did I got all these details prompts? Well, all the preparation was made together with Claude Code Opus model, or you can do that with ChatGPT 5.5 or any SOTA model really. What I did there is that I explained and sort of groomed my idea with that model and asked it to build me a very detailed plan with small steps. Since I was not asking for code etc., there was very little token spent, and I just got the list of 20 prompts, like each representing small task. Of course, along the way, I had to go back and forth and adjust a little bit depending on the result. But overall, that plan worked well. Of course, in my initial test, I tried to do some one-click magic, and unfortunately, I failed. I failed quite a lot of time, and I almost frustrated that enough that I thought like I'm gonna abandon this video because everyone basically expect this. However, since you guys was asking a lot about it, I think this will be valuable for you to not have any delusions about it, and only for you guys to figure out how to make use of it. Now, I covered quite a lot of problems, but there is also a bright side. It actually can do the thing. Well, look at this graphs that it creates, the blueprints, and that is pretty sick. Well, I mean, you can see that they're pretty accurate. It follows my prompts exactly, and I'm actually starting to think that this approach is quite good in general, because when you provide enough details and without deep thinking, it does the job way faster. And that was actually surprising to figure out since I was working with local LLM. Time to time, I was taking a look on my GPU if it's about to burn or no. And after 10 consequent prompts, we are ready to do the very first test. I just set the input, some simple actors, and here we go. We do have UI, and we have this cutlet floating, where well something actually works. And I almost forgot that prepare 3D asset as I mentioned, but I did not create them manually. All of them was generated by Triple. Here you can see them in Unreal Engine, and here's how I created them in just 10 minutes. Here are all my images created with ChatGPT. Now we're gonna go to model and we're gonna go batch images to 3D. Yes, I'm pretty lazy to go create it one by one. You can do it up to 30 models at once. So let's drop them here, and we do not need 8K texture this time. We can definitely go with 2K or 4K. I definitely want to try PBR, and for poly counts, of course, we are not going to go with 2 millions. I think for each piece, around 30,000 will be enough just to get really nice looking 3D models. And we can hit generate and go bring coffee. In a while, we do have all 3D models ready, and they look fantastic with the poly counts that we wanted. And now we are ready to take them back to Unreal Engine. We can go to manage batch export and select all the assets that we want to export, and do it all at once in any format, let's say in GLB. And Triple, by the way, is still top 1 3D AI generator by multiple categories such as texture and geometry. And that is why me and my team using it all the time for most of my workflows. And of course, if you want to try, link in the description, and it also will grant you additional 800 free credits. Now, first test successful, we do have still 5 more prompts to go. And next prompt is to tweak the interactivity, and now we must be able to actually drop the piece and it must land on the burger. So let's do that. The prompt is done. Let's give it a test. Okay, and yes, it works. Oh my god, guys, if you can imagine how many unsuccessful tries there was before when I was using the wrong approach, but when I got that master prompts and other prompts prepared, I actually start to get great results. Well, I of course do not mean that you need to prepare every prompt with advance and pretty much like working with CloudCon on the side. No, I was talking more about keeping that main context and main direction. So every new prompt basically adds something. So with every new task, it doesn't have to rethink it through, which can lead to errors and double work. Well, actually that can happen even with SOTA models. If you start new chat, for example, and then it can change something in different way and you are debugging that, and you know, like that sort of a problem. I of course also was addressing some bugs. And by the way, for the background, my idea was that we sort of like growing to the stratosphere, and there will be a big guy, sort of like, like burger monster, right? The image itself, I of course generated with ChatGPT. Technically, you can try connect any image generation API as well, but I'm really used to do that different way, and there's plenty of ways how you can generate images for free, such as with Gemini or ChatGPT free plans. And bit by bit, detailed prompt after detailed prompt, some debugging, hours of testing, I got my Unreal Engine game built with local LLM ready. Guys, this is absolutely crazy. The result is on your screen. I'm gonna read comments. Drop your feedbacks to the comments. I really want to know what you think about it, guys. And now it's time to do the honest summary. So first of all, running that LLM really requires quite a lot of GPU. And I would say realistically, if you have less than 12-14 gigabytes of VRAM, better not even to try. Because again, you're also gonna need some VRAM for Unreal Engine, etc. What you can try instead, with this same setup, you can try to connect DeepSeek, for example, which is extremely cheap, and you can even get some API keys for free to start with. Second thing, even if you're lucky or luckier than me and have more than 24 gigabyte VRAM, to work with local LLM efficiently, you definitely need to know what you are doing. Then it can be quite good assistant and help with routine tasks. Maybe batch task, like go and replace some variables, go change all the blueprints to do this and this and this. That definitely works, and I proved that. While if you're a complete beginner and expected to work with prompts like I needed to work like that, just do it for me, don't ask any questions, well, then most likely you're gonna be frustrated. You can try playing with bigger context, higher reasoning efforts, but at least at this moment, it's not gonna work well. But I still think this is absolutely amazing how good local LLMs are. Even getting to this point for me was unimaginable even like 6 months ago. Now you see what you see. That was Steph. Like and subscribe, and I see you in the next video.